Pythagorean theorem says that if a squared plus b squared equals c squared, then the side lengths that are given are the side lengths of a right triangle. We cannot say that the lengths that are given are the sides of a right triangle unless it fits a squared plus b squared equals c squared. Okay, so what I'm going to do now is I'm going to show you, I'm going to give you one example where it is or isn't, and one is and one that's not, or vice versa. Okay? I'm going to show you how we can determine whether or not the side lengths given are the sides of a right triangle. Okay, so let's go ahead and do this example. Is this example 4? Yeah. Okay. So for example 4 and example 5, we're going to do these kind of together. Okay? And then we have one more example after this and we'll be done. Okay? For both these examples, I want you to use these directions. Tell whether, okay, the triangle with the given side lengths is a right triangle. Okay? So this is, I'm using this for both example 4 and 5. All right, here we go. 7, 11, 13 for example 4, and 15, 36, and 39. There's my second example. Okay, first of all, class, tell me right now, do you know what side lengths would be the legs of example 4, and why?
7 and 11.
Why would Brennan 7 and 11 be the lengths of the legs?
Because they're shorter than
Exactly. Everybody understand that? That the legs will always be the two shorter lengths of the two of the three will be the shorter of the three, or the two shortest. Okay? So obviously the two legs are 7 and 11. The hypotenuse then will be represented by what side leg? 13, right. So we need to put this into Pythagorean, we need to put 7, 11, and 13 into a squared plus b squared equals c squared. And if the sum of the two shorter sides squared equals the length of the hypotenuse squared, then they are the sides of a right triangle. Okay? So we're going to go 7, or a squared, plus b squared has to equal c squared. So we're going to represent a as being 7. So 7 squared plus 11 squared has to equal 13 squared. If these two squared and added together does not equal 13 squared, they are not the sides of a right triangle. What's 7 squared? 49. What's 11 squared? 121. 13 squared is 169. What is 121 plus 49 become?
170.
170. Does 170 equal 169? So therefore, what are we going to put? We're going to put this as not a what triangle? Right. This is not a right triangle. Because a squared plus b squared does not equal c squared. Does that make sense? All right, let's see if this other one is. What are my legs? And what are my legs?
36.
Good. 15 and 36 are the legs. What's the hypotenuse? 39. So we're going to go a squared plus b squared has to equal c squared. A is 15 squared plus b, which is 36 squared, has to equal 39 squared. Okay? 15 squared is 225. 36 squared is 1,296. Yep. 39 squared is 1521.
Yep.
Okay? Add these two together.
1521.
So since the sum of the legs squared equals the hypotenuse squared, are these the sides of a right triangle? Could it make a right triangle? Yes. So then we're just going to say right triangle, and that's our answer for this one. Okay? If they don't equal c squared, the sum of the two shorter sides squared, then they're not the sides of a triangle. If the sum of the two legs squared equals the hypotenuse squared, then it is a right triangle. That makes sense.
How much more?
All right, we got one more example, we're done.
I thought you said this would take like 50.